for today is the chapter 5 and chapter 6, the DC and AC bridge.
Boleh sir, boleh.
All right. Okay, so let's start our lecture for today. Okay, so that I mentioned to you. So our today is just focus on the DC, DC bridge. Okay, actually, so this is all notes. Actually, the chapter 5 is the DC and AC bridge. Okay, but for this semester, actually, we divide by 2 chapter lah. For chapter 6, chapter 5 is the DC bridge, and chapter 6 is the AC bridge lah. Okay, but for today, we just cover for DC bridge. All right. So before that, I just give a soft reminder. So don't forget our midterm test is on this Thursday. Okay, 8 to 9:30 lah. All right. Are you ready, guys, for the midterm test? For the midterm. All right. Okay. So I just give some tips, some tip for the midterm test. All right. So that I mentioned to you. Okay. For the midterm test, we have 2 questions. Okay. Question number 1 relate to the chapter 1 is the introduction to instrument and measurements. All right. So on the chapter 1, we have 2 questions. Okay. The question divide by 2 another sub question lah. So the first question is we give the table, so you have to calculate lah the precision, the standard deviation, and so on. Okay. On the B is the limiting error. Okay. On the B, second question is the limiting error. That is for question number 1. And then for question number 2 will be on the DC voltmeter. Okay, DC. Okay, DC. Okay, for question A, question 2A is the multi-range. Okay, multi-range emitter, and question 2B is the multi-range. Okay, voltmeter. All right, so this is for the tips lah. Okay, hope you can prepare lah. All right, for the midterm test. Okay, only 2 chapter, chapter 1 and chapter 2. Okay, all right. Okay, so tomorrow is no class. I just give you some time to revise. Okay, to do revision on your on the midterm test. Okay, all right. So just today class, all right. For tomorrow, so we don't have the class. So just you have to focus your midterm test. Try try to do some revision on the chapter 1 and chapter 2. Okay, so tomorrow no class. Okay, and today we just focus on the DC bridge. Okay, so on the DC bridge, normally we have 2 techniques lah. We have the Wheatstone bridge, and another one we have the Kelvin bridge lah. All right, so the bridge actually is the instrument to measure the resistance, inductance, and capacitance, and also we can measure the frequency. All right, that is the function of the bridge lah. Okay, the function of the bridge is to measure the resistance, inductance, capacitance, and also the frequency. Okay, for DC bridge, normally we measure the resistance. For DC, okay, for DC bridge, normally we measure the resistance, and for AC bridge, normally we measure the inductance, and also we measure the capacitance, and also we can measure the frequency. Okay, that is for AC bridge. Okay, for DC bridge, normally we measure the resistance. Okay, for today we on DC bridge. Okay, DC bridge. That means the function of the DC bridge is to measure the resistance. All right, so this is an objective for our topic is explain. So, okay, number 1 is the explain how a simple DC and AC bridge circuit operates and derive an expression for the unknown parameter. So that I mentioned to you, for DC bridge, normally we have 2 techniques. There is the Wheatstone bridge, and another one is the Kelvin bridge that we go for today. And for the AC, we have 4 techniques. Okay, we have 4 bridge. Okay, that's maybe on the next week I will explain on the AC bridge. Okay, and then every bridge will be have a different equation. Okay, that's why you have to know the how bridge circuit operates and derive the expression for the unknown parameter for every bridge. Okay, for the for DC is the and also the to X and DC and AC bridge and derive the balance equation okay, that I mentioned to you. So every bridge we have the different equation right? So this one you have to know how to derive the equation on the every bridge. Okay, and then identify each bridge by name that I mentioned to you. For DC we have 2 bridge and for AC we have 4 bridge That's why you have to know you have to know every bridge. Okay, and also you have to know how to derive the equation on every bridge Okay, for the DC we have 2 bridge, is the Wheatstone bridge, and also we have the Kelvin bridge Okay, and AC we have 4 bridge. Okay, will be covered later on. Okay. All right. So next we go for the dimension 2 is the Wheatstone bridge. So let me to measure the resistance based on the Wheatstone bridge. Okay, you can see. So this is on the figure. All right, on the figure 4.1, this is the Wheatstone bridge circuit All right, so we have the R1, R2, R3, and also the R4 Okay, so and actually this is the portable digital DC bridge You can see this one So actually this is inside the this portable DC bridge So this is the Wheatstone bridge circuit Okay, so the Wheatstone bridge remain the most sensitive and accurate method for precisely measuring the resistance value Alright, so the function of the DC bridge or for the Wheatstone is to measure the resistance that I mentioned to you for DC normally we measure the resistance. Okay, for Kelvin or for Wheatstone we measure the resistor Okay, but the Wheatstone bridge is more sensitive and accurate method compared than Kelvin. Alright, so the Kelvin is to measure the low resistor. Okay, to measure the low resistor Okay, you can see this one So this is a Wheatstone bridge. Okay, you have to remember. So this one we have the R1, okay, R2, R3, and also the R4. Okay, but some of the books, okay, some of the book they refer, for example, okay, for example, this is R1, this is R2. Okay, some of the books. Okay, and also on this slide, for example, next we go for the example. So they use this one is the R3. Okay, sorry, this one the R3 we use the R2 Okay. Right, so that I mentioned to you so some of the book, okay, some of the book this refer this one is the R1, this one is the R2, R3, and R4 okay. For this case, okay, for this case we refer this one is the R1, R3, R2, okay, this R2 and R4. Right, so please make sure so when you derive, please make sure the position of R Some of the book refer this R3 is the R2, some of the books and also for this slide after this we go for the example. Okay, so the example refer this one as the R2. Okay, that's why when you derive, make sure you have make sure you have to know the position of R. Okay, the resistor Okay, that's why you have to know this is for example this one you use okay, but some of the book refer to the R2. Okay, all right, so the fundamental concept is two divider voltage divider. both feed by the same inputs. Okay, right? You can see this on this graph, this circuit here, Wheatstone bridge here. Okay, so the circuit output is taken from the both voltage divider outputs. Okay, and then the galvanometer. Okay, galvanometer we put here on the output here. Okay, very sensitive DC current meter is connected between the output terminal on this part lah. We put the galvanometer to measure the current Okay, if unbalanced, so this galvanometer will be the current value lah. Okay, but for example, if this is balanced circuit, that means so this is not will be appear on the zero lah, on the null indicator will be appear the zero. Okay, right? If two divider voltage divider have exactly the same ratio, okay, that means the R here, R1 here, voltage R1 and R3 will be same. Okay, R2 and R4 will be same. Okay, that means so the bridge is the balance. Okay, this bridge is the balance and no current flow. Okay, on the direction on both directions. All right, through the galvanometer lah. That I mentioned to you. So if the circuit balance, that means R1 here and R3 is the same. Okay, the voltage the voltage the same, and also the R2 and R4 will be same. So there is no current flow here. Okay, that means our indicator for galvanometer is the zero. Okay, will be indicate the zero value here. Okay, right. This is the balance. If, for example, this circuit is is the unbalanced, that means we have, so the galvanometer will be appear the value of the current. All right. If unbalanced circuit. Okay, for unbalanced circuit for Wheatstone bridge here. But if the balance circuit, okay, the balance circuit, that means the R voltage for R1 is equal to R3, voltage R2 equals to R4. That means this circuit is the balance, so no current flow on the galvanometer. So the galvanometer will be indicate the zero value. All right. Okay, so this is you can see the equation here. All right. So the voltage that I mentioned to you, voltage R1 and R3 is the same. That's why you can see this one. Okay, R1. Okay, to find the voltage in the R1. So this is formula lah. Okay, voltage is the R multiplied by R. Okay, so this is we assume as the R1 here. Alright, R1 multiplied by R1. Okay, I1 multiplied by R1 here equals to, okay, we assume this one is the I2. Okay, I2. Alright, so that's why some of the book refer this one is the R2. Okay, that's why here will be R, okay, I2 multiplied by R3. Okay, but some of the books refer to I2 multiplied by R2. Okay, depends on the okay, the position here lah. Okay, for example, this is R3 lah. That's why this one I2 dot multiplied by R3. Okay, and then actually this is we call as the, okay, in R2 we can call as the R3, actually R3. So R3, okay, for example, for voltage here, so R3 multiplied by R2, okay, for voltage here, but R1 and R3 is same. That's why we be changed to R1 multiplied by R2. That means voltage current here, okay, current here will be same with current here. Okay, right. So this one we declare as the I1. This one also I1. Okay. Initial maybe I declare as the I3. That means I3 equal to I1. That's why you can change. This one will be I1. Okay, here. So I1 multiplied by R2. Okay, for voltage here.
Doktor tak dengar.
Okey. Boleh? Dengar tak? You want to me repeat from the previous slide or
Repeat doktor.
okay. Wait, I open share. Alright, can you see the slide here for DC and AC bridge?
Yes, Doctor. Yes.
Okay. So okay. So how about the midterms? Are you ready for the midterms? I have to repeat again. So okay. Before this, I already explained about the midterm test that I mentioned to you. So we have two questions, all right, for the midterms. Okay. So the first question is relates to the chapter 1 for the introduction to instrument and measurement, and question on the DC lah. Okay. Alright, so for the chapter 1, we have two questions. Okay, chapter 1, question 1, we have two sub question. Okay, question A is the on the table, we give the table, so you have to calculate the precision and standard deviation and so on. And question B will be on the limiting error. Okay, limiting error. Okay, that is for question number 1, and question number 2 will be on the DC. First is the multi-range emitter. Okay, multi-range emitter. And second one, okay, for the question 2 is the multi-range voltmeter. Okay, that is the tips lah, the tip for the midterm test on this Thursday. Okay, so 8 to 10 lah, 8 to 10. Right, so for today, we focus on the DC, okay, and AC bridge. Okay, that mentioned to you. Actually, the chapter 5 is the DC bridge, and chapter 6 is the AC bridge. All right. So for DC bridge, normally we have two techniques. We have two bridge. Okay. For example, we have the Wheatstone bridge and we have the Kelvin bridge, and also the AC we have 4 bridge lah. I will explain it maybe next week for the AC bridge. Okay. So tomorrow no class. Okay. I just give you time to do the revision for the just prepare for the midterms. All right. Tomorrow no class, but today we focus on the DC bridge. Okay, so for DC bridge, actually the function of bridge, okay, here is to measure the resistance, okay, to measure the inductance, capacitance, and also we can use to measure the frequency. Right, this is the function of bridge. Okay, for DC bridge. Okay, for DC bridge, normally we measure the resistance. Okay, we measure the resistance. Okay, for DC bridge, normally we measure the resistance, and for AC bridge, we measure the inductance, capacitance, and also we can measure the frequency lah. Okay, so this is a learning objective for topics number 5 and 6. Okay, explain how a simple DC and AC bridge circuit operates and derive an expression for unknown parameters. All right, and then second is the explain the step involved in balancing and DC and AC bridge and derive the balance equation. So that I mentioned to you, for example, like DC bridge, we have two bridge. We have the Wheatstone bridge and also we have the Kelvin bridge. So every bridge we have the difference equation. Okay, that's why you have to derive lah. You have to derive from the circuits, okay, and then we can get the balance equation lah. You have to get the balance equation, and also for AC we have 4 bridge, okay, bridge, and then every bridge will be difference equation. Okay, that's why you have to know how to derive, okay, how to derive every bridge lah, and then to identify the each bridge by name lah. Okay, that I mentioned to you. For DC we have 2 bridge, okay. We have the Wheatstone bridge, and also another one is we have the Kelvin bridge lah. That is for DC. Okay, And AC we have another 4 bridge. Okay, we have Maxwell, okay, Wien's bridge, and so on. Okay, we have 4 technique. Every bridge will be different equation. All right, so we go for the DC bridge, for Wheatstone bridge that I mentioned to you. Okay, the function of the Wheatstone bridge, okay, is to measure the resistance, using the Wheatstone bridge here. Okay, this is a circuit for Wheatstone bridge. Okay, you can see this one. So this is circuits. Okay, and also this is the equipment. Okay, the equipment we call the portable digital DC bridge. Okay, this portable digital DC bridge is to measure the resistance. Okay, to measure the resistance. Okay, you can see this one. The Wheatstone bridge remain the most sensitive and accurate method lah. Okay, right, to measure the resistance. So the Wheatstone bridge is most sensitive and accurate method compared then we use the Kelvin. Okay, the Kelvin is normally we use for low, okay, for low resistor. Okay, for low resistor lah, to measure the low resistor, that we have to use the Kelvin. Okay, for accurate, okay, and sensitive we use the Wheatstone bridge lah. So you can see this one. So this is we call the Wheatstone bridge. Okay, this is R1, R3, R2, and R4. Okay, they mentioned to you some of the books refer to this one R1. This is R2. Okay, this is R2. This is R3, and this is R4. All right, but some of the books are, and also on this slide, okay, on the example, they use this one as the R2. Okay, this one is the R2. Okay. All right, you can see this one. Okay, the fundamental concept is two divider, voltage divider, both fit by the same input. Okay, the same input. This one, you can see this is a Wheatstone bridge. Okay, the input will be same, and this is the output. Okay, the output will be put the galvanometer here. Okay, we put the galvanometer here. Right, so the circuit output is taken from the both voltage divider outputs, and then the galvanometer is very sensitive DC current meter, is connected between the between output terminal here, and used to monitor the current flow from voltage divider to others lah. Okay, for example here, so if the circuit is the balance, okay, the balance, that means R1 equal to R1 voltage here equals to R3. Okay, R2 equals to R4. That means our circuit is balanced, so no current flow in the galvanometer lah. So the galvanometer will be appear the zero value. Okay, if okay, this circuit is the balance. Okay, if the circuit is the balance, that means R1 voltage for R1 equal to voltage R3, voltage R2 equal to voltage R4. That means, okay, so this is a balance lah. So no current flow on the galvanometer, and then galvanometer will be appear will be indicate the zero value. But if this circuit is unbalanced, so this galvanometer will be show the current flow lah. Will be indicate the current flow. Okay, on the galvanometer lah. That is we call the unbalanced. Okay, unbalanced circuit lah. If okay, the voltage, for example, voltage R1 is not equal to R3. That means, so we will give the current flow here, okay, on the galvanometer. But if the circuit is balanced, okay, if circuit is balanced, that's mentioned to you, R1 and R3 is the same, okay, R2 and R4 is the same lah, okay. That means our galvanometer will be no current flow and will be indicate the zero value, right? That is we call the balance lah. Okay, this is equation okay, that I mentioned to you. All right, so this is assumed as the, okay, we assume as the R1. Okay, so this is we assume as the I1. Okay, this assume as the I2. Okay, so this we assume as the this is I3. Okay, this one I4 lah. We assume as the I4. All right, so that I mentioned to you, if this circuit is balanced, that means voltage here will be same with voltage here. That's why you can see this one. Voltage is equal to IR. Okay, multiplied by current multiplied by resistor lah. So that's why current here will be, okay, I1 multiplied by R1. Okay, this one voltage here equals to current I2, okay, multiplied by R3 here. Okay, this one and also this one actually we get like this lah, I3 multiplied by R2, okay, equals to I4 multiplied by R4. Okay, normally actually this one I1 is equals to I3. That's why here will be changed to I1 multiplied by R2, and also I2 equals to I4. That's why here will be changed to I2 lah. I2 multiplied by R4. Okay, and then we divide equation 1 and equation 2 will be this. We got this formula lah. R1 divided by R2, okay, equals to R3 divided by R4. But some of the books refer to the R1 divided by R3, okay, equals to R2 divided by R4. Okay, actually this one is the same. Okay, this one is the same. Depends on the position of R3 and also R2 here. Okay. Alright, for example, this one, they refer this one is the R3, but some of the books, okay, some of the book refer this one is the R2, okay, and this is R3. Okay, that's why you can see these two formula here. Alright, but actually it's the same formula, just a position of the R3 and R2. Normally normally some of the book refer to this one as the R2, okay, and this is the R3. Some of the book, this one refer R3 and this is R2. Okay. Right. So they mentioned to you if one of the resistor change, okay, even a little bit value, for example R1, okay, so the bridge will become the unbalanced. So unbalanced here, and then the galvanometer will be indicate the current flow lah. So the current flow here. Okay. So they mentioned to you if the balance, that means voltage here will be same with this one and this one, so the galvanometer will be appear the zero value lah. Okay, the null. Okay, the null. That means the zero value. Okay, that is the balance lah. Balance. Alright. So this one measure resistor measurement. Okay, using the Wheatstone bridge, you can see. Okay, using the bridge null indicator indication principles. Okay, for resistor measurement, R4 in the circuit is replaced to Rx. Okay, normally this is R4. Okay, we change. Normally this unknown lah. Okay, Rx is the unknown resistance. We change this unknown resistance, and R2 is the variable. Okay, R2 is the variable. That means we can adjust the R2 so that the galvanometer will get indicate the zero lah. That means the circuit will be balanced, and then the galvanometer will be indicate the show value, will show the zero value here. Okay, okay, the zero value. Okay, that is the how to measure the resistance. How to measure the resistance. You can see this one. That before this, so the R4 will change to the unknown resistor. Okay, for example, we want to measure this Rx here. All right. R2 we have to change to variable resistor lah. Okay, we have to change the variable resistor, and also when we put the galvanometer here, so we'll be introduced the RG here. Okay, will be introduced the RG. Okay, that's why the RG is the internal resistance for the galvanometer lah. Okay, so when we get this cut, so to measure this Rx, so we have to adjust this R2. Okay, we have to adjust the R2 so that the galvanometer indicate the value. Okay, for example, this is to get the zero value here, then we can measure the Rx lah. Okay, this is formula to measure the Rx. Okay, R2, okay, multiplied by R3 divided by R1. Okay, but some of the book refer to R3, okay, multiplied by R2 divided by R1 lah. Okay, depends on the dimension, depends on the position of R3 and R2. Okay. Okay, but some of the book refer shown as this, follow this one lah, R3, but some of the book refer this one as the R2 lah. Okay. All right, so sensitivity. So when the bridge is unbalanced condition, okay, that means that one of the resistor is not same. So that means our circuit will be unbalanced. So current will be flow lah through the galvanometer and will be causing the deflection. Okay, deflection occur because of the current flow to galvanometer lah. All right. Okay, the amount of deflection is a function of the sensitivity of the galvanometer lah. Okay, the sensitivity is defined as the deflection per unit current. Okay, this is formula for sensitivity. And then to calculate the deflection, this is formula for deflection lah. Okay, sensitivity multiplied by current. Okay, deflection to formula for deflection, sensitivity multiplied by current. Okay, that is formula to calculate the deflection. Okay. Alright, so next we go for the Thevenin equivalent voltage. Alright, so to determine the amount of deflection that would result for the particular degree for unbalanced, okay. So we remove the galvanometer here. You can see, we remove galvanometer from the bridge, and then the amount of current flow the meter to be obtained by using the Thevenin equivalent circuits, okay. Alright, and then compute the open circuit voltage, okay, voltage divider, terminal A and B, this one, this point at the output here, apply the voltage divider. So this is formula for voltage divider lah. Okay, this one VA, for example, this point lah. Okay, this we call the VA. Okay, and then this one is the VB. Okay, that's why this is formula voltage divider rule lah. Okay, to calculate the voltage VA, alright, so R3, okay, divide by R1 plus R3 multiplied by V. Okay, that is formula for voltage divider rule lah. Alright, and then to calculate the VB here, okay, R4 divide by R1 plus R2 multiplied by V. Okay, this is to calculate the voltage here. Okay, this point now, for example, this point, okay, this point to this point VA, and this point to this point we declare as the VB. Okay, this one VA and this one VB lah. Okay, this is a standard formula for voltage divider rule, right? And then the different, okay, in VA and VB represent as the Thevenin equivalent circuit. So this is the voltage Thevenin lah. That means VA minus VB. Okay, we substitute the equation we got here. Okay, VA and VB. So we substitute to this equation lah. Okay, VA minus VB. So this is VA and minus VB and simplified. So we get this one lah. Okay, this is a equation for Thevenin. Okay, this is equation for Thevenin. Okay, next we have to calculate the resistance. Okay, so for example, actually when we simplify this circuit, we have like this lah. So this is our something like this for circuits. Okay, from the Wheatstone bridge. Okay, if we simplify, we gain like this. So this one we call the voltage Thevenin, and then this one is the resistance Thevenin, and this one is the RG, is the galvanometer lah. Okay, this is resistor for galvanometer. Okay, this is okay, now we know to get the voltage Thevenin here using this formula, and then next we have to calculate the resistance Thevenin. Okay, resistance Thevenin. All right. Okay, so when we want to calculate the Thevenin equivalent resistance, so setting all source to the 0, that means it's the short circuit lah. Okay, setting all source to the 0, voltage source are replaced by short circuit and current source by open circuit lah. Okay, so if we have the voltage, okay, you can see on the Wheatstone bridge here. So okay, this one will be short. Okay, this one will be short lah. Okay, this one will be short, short circuit. Okay, but for example, if this one is the current, that means it will be open lah. Okay, this one will be open circuit. But now this one, the Wheatstone bridge, this is the voltage. Okay, the voltage will be short circuit here. Will be short circuit, will be get like this lah. Alright. Okay. Alright, you can see this one. So and then we can get the voltage resistor here. Alright. So as you can see this one, R1 and R3 is the parallels. Okay. We assume as the RA. Okay, the RA is equals to R1 parallel with R3, and this one we declare as the RB lah. Alright, RB is equals to R2 parallel with R4. Okay, and then R total equals to RA plus RB. Okay, that's why you can get this equation lah. Okay, this one to calculate the RA and this one to calculate the RB. Alright, this one is we call the resistor Thevenin. Okay, this one we have to calculate the resistor Thevenin. So this formula lah. Alright, so this formula to calculate the parallel. So the R1 multiplied by R3 divided by R1 plus R3. Okay, plus R2 multiplied by R4 divided by R2 plus R4. Okay, this is the to calculate the resistance Thevenin lah here. Okay, that's two value you have to calculate lah. First, you have to calculate the voltage Thevenin. Second, you have to calculate the resistance, okay, Thevenin. Then you can get the current Thevenin lah. Okay, current Thevenin. Okay, so we know the voltage. Okay, we know the voltage Thevenin, and also we know the resistance Thevenin. We can calculate the current Thevenin lah. Okay, so maybe you can try example. Okay, you can see this one. That's why some of the book refer to the R3, some of the book refer to R2. Okay, this one, for example, okay, the example here, we use the R2. Okay, that's why you have to make sure. So on the position of R2 and R3. Okay, some of the book refer to the R2, some of the book refer to R3. Okay, but the both equation is correct lah. Okay, because of the position, the position of the R2 and R3. Okay, so this is an example. Okay, first we have to calculate the. Okay, we got this example. We have to calculate the voltage Thevenin. Okay, we have the formula, and then we have to calculate the resistance Thevenin. Then at the end we can calculate the current Thevenin lah. Okay, so the equation here determine the current through the galvanometer lah. That means here current Thevenin. We have to calculate this one lah. But to calculate the current, we have to calculate the voltage Thevenin lah. Okay, so this is formula formula for current Thevenin. Okay, right, so you can see this one. Okay, our voltage supply is the 6 volt. All right, and then R4, our R4 is 10 ohms here. Okay, 10 divided by 2.5 kilo plus 10 kilo, right, minus 3.5 kilo divided by 1 plus 3.5 kilo lah. Okay, so this is we can calculate. We got this one lah. Okay, this one we call the voltage Thevenin. Okay, some of the book refer to voltage Thevenin. Okay, as you can name as the VTH, also ETH. It's the same lah. Okay, so we calculate the VTH, we get 0.132 volts. Okay, this is for voltage Thevenin lah. And then next we have to calculate the resistor lah, Thevenin. Okay, resistance Thevenin here. Okay, using the formula here. Okay, straightforward using the formula. All right, so R1 multiplied by R3 divided by R1 plus R3. Okay, and plus R2 multiplied by R4 divided by R2 plus R4. Okay, that is formula. All right. Okay, you can see, but you can see the position of R2 and R3. So this is R2 and this is R3 lah. Okay, and then calculate. Okay, we get the Thevenin is the 2.778 kilo. Okay, ohms. Right, that is the resistance Thevenin lah. And then I mentioned to you, this is overall circuit. Okay, so this is we calculated, we get like this, and then we can we get like this for RTH, and also this is given. Okay, the galvanometer resistance is a given 300 ohms, and then automatically we can calculate the current Thevenin lah. We call the current Thevenin. Okay, or IG. It's okay. All right, so we'll be same name lah. Okay, so this is to get the current Thevenin lah. That means the voltage Thevenin divided by resistor Thevenin plus RG. Okay, that's the current through the here. Okay, will be through current through the galvanometer lah. Okay, this IG, or we call the Thevenin lah, or current total. You can assume as the current total lah. Current total. Okay, this one So the current total is the 42.88 microampere. Right. So this is some example They use the Wheatstone bridge. Okay. Alright, so this is some application using the Wheatstone bridge. Alright, so we have, for example, we have two application using the Wheatstone bridge. First is the strain gauge, okay, which change their internal resistance according to the specific level of strain, okay, serve as the unknown resistance. Alright, so you can see this one. For example, we have this one for circuit number 1, we have 4 active gauge. Okay, that means every we can measure lah. So this one we can measure. This one we have full bridge lah. We have full bridge. We call a full bridge. That means every bridge we can measure the strain gauge. Okay, and also we have the half bridge. Half bridge, that means we have only two gauge here. Okay, strain gauge here, and also we have the single gauge. Okay, normally for normally we have only one okay, that means this one for example, before this we have the Rx here, so we want to measure the strain gauge here, depends on this value lah. Alright, so that is function for strain gauge lah, the function of Wheatstone bridge. Okay, for example, this one, if we put 2, this means we have Rx, this one maybe another one we call the Rx2, this is Rx1 lah. Okay, this is unknown lah, this is unknown, this is also unknown lah. Alright, so the concept will be same. Normally for simplicity we use this one okay, that means we have only one Rx here. Okay, only one single gauge here. Okay, single gauge here, and then this strain gauge we measure this one based on this value lah. Okay, based on this value Rx here. Okay, and actually is this is we call the variable resistor lah, variable resistor so we can adjust. We want to measure this value, alright, Rx, we have to adjust this one, the R3, so that the galvanometer here, the volt will be indicate the zero value lah. Okay, the zero value, then we know the value of Rx. Okay, and then for second application using the Wheatstone bridge is the locating the ground fault. Okay, for example, when we build the buildings, okay, house, so we have to put some ground fault, right? Everything, okay, everything source, okay, we have the overcurrent, over voltage, so the overcurrent or over voltage go to the ground lah. Alright, that's why we cannot simplicity to put any ground. That's why we have also theoretical to measure the good, okay, the good ground lah. Okay, for example, the application this one okay, this is how we locate the ground fault lah. For example, for the building, okay, for the house. Alright, the second application for the Wheatstone bridge lah. Okay, so normally used by electrical power distributor to locate the break in the power line, or two lines shorted together, or single line shorted to the ground. Okay, for example, this is we call the Murray loop test lah. Alright, so similar like our Wheatstone bridge lah. Okay, so actually this is our length conductor our conductor LA. This is good conductor. We call a good conductor is the LA, and also the LB is the defective conductor. Okay, and also the LX we have to measure lah. Okay, LX, we have to measure the length of LX to put the grounds. Okay, to put the ground here. That is the application for the second application for the Wheatstone bridge. Okay, this one, the defective conductor of the length B is connected at its cable terminal to the healthy connector lah. Healthy connector of the length A here. You can see on this figure. Right, so this is LA and this is LB. Okay, LA is the good conductor and LB is the defective conductor, and this is we have to measure the LX to put the ground, okay, the location of the ground. All right, and then the loop formed by this conductor is connected to the test set. All right, so the bridge is balanced. Okay, the bridge is balanced when we adjust the R2. Okay, so this one, we adjust the R2. This is variable resistor lah. So we have to adjust the variable resistor so that this indicate the zero lah. Okay, the zero value. All right. Okay, so you can see the ratio of R1 to R2 is generally known as the ratio of RMS lah. Okay, and then this is formula, formula for balance lah. Okay, formula for balance. R2 equals to R1. Okay, this one, you can see this one. Okay, that means R2 equals to R1 divided by this position, and also, okay, this is RA plus RB minus Rx divided by Rx. Okay, this one, this part. Okay, this one we call as the RA. Okay, this one is the RB. Okay, this one is the Rx. Okay, that's why you can get this equation lah. Okay, so RA, okay, plus RB here minus with Rx. Okay, divide by Rx. Okay, that is the ratio lah. Okay, the ratio so that the circuit is the balance lah. Okay. Okay, this is equation for the balance. This is equation for the balance. And then you can see to calculate the resistance. Okay, to calculate the resistance, we have to use this formula lah. Okay, the resistance actually, the formula of resistance, rho. Okay, rho is the sensitivity, resistivity. Okay, multiplied by length divided by cross sectional area. Okay, this is actually this formula for calculate the resistor lah. All right. Okay, that means rho multiplied by length. Okay, divided by area. All right. So and then from this, okay, from this equation, okay, we can derive like this lah. Okay, so for example, we can cross multiply. So this one will be cross this one, and this one will be cross this one. So we get like this lah. Okay, R2 multiplied by Rx equals to R1 multiplied by RA plus R1 multiplied by RB minus R1 multiplied by Rx. Okay, you can see this one. From this one, we multiply cross, and then at the end we can get like this lah. Okay, because we want to calculate the Rx here. Right, so and then we substitute the Rx, okay, to this, all the Rx will be appear like this lah. Right, so will be Px multiplied by Lx divided by Ax. Okay, and then we get like this. Okay, but we assume, okay, we assume the both conductor is the same material. That means this row will be same. Okay, we can cancel out this row. All right, and the cross sectional area is the same. So that means we can cancel out the A and row here. So at the end we can get like this. Okay, the last equation we get like this. Lx equals to R1 divided by R1 plus R2 multiplied by LA plus LB. Okay, and also if we assume the LA, okay, LA and equal to LB, so automatically the formula will be like this lah. Okay, to calculate the Lx the length. Okay, the length for Lx here on, you can see on the here. So we want to, from this point to this point, we want to calculate the Lx so that we can put our ground. Okay, we can put our ground here, so that is the best, okay, the best location for our ground lah. Right, so using this formula, okay, using this formula lah. That's why it's not simplicity, we can put any ground. That's why we have, for example, for they have the formula to calculate the ground lah. Okay, the length of the ground. Okay, for example, use this one lah. Okay, R1 divided by R1 plus R2 multiplied by 2L. Alright, that is formula to calculate the okay, Lx. Okay. Next, we go for the Kelvin bridge. Okay. So next, another for DC. Okay, for DC bridge, we have the Kelvin bridge lah. Actually, it's the similar like Wheatstone bridge, yeah. But we have some modified version on this part. You can see on this part we have the RY. Okay, we have the RY. So the rest will be same. Okay, you can see before this is the Wheatstone bridge, but on this part we have the some position lah. We have put three position. We have the RA, point A, point B, and point C. Okay. Okay, so the purpose of modification here is to eliminate the effect of the constant and lead resistance when measuring the unknown low resistance. Okay, that mentioned before this, mentioned to you. So the function of the Kelvin bridge is to measure the low resistor lah. Okay, the range from 1 ohms to 1 micro ohms lah. Okay, to measure the low resistance, we have to use the Kelvin bridge lah. Okay, that mentioned to you the advantages of the Wheatstone bridge is more accurate compared than Kelvin, but we have to use the Kelvin because of the unknown low resistance. For example, we know this Rx is low, so that's why we can use the Kelvin bridge. Okay, Kelvin bridge. So the range of the low resistance is from 1 ohms to 1 micro ohms. Okay, can be measured with high degree of accuracy using the Kelvin bridge. Okay, that's why the Kelvin bridge function is to measure the low resistor lah, low resistor. Okay, on this part, you can see on this part. Actually the Rx is the combined is the R here and R here. So for example, Ry equal to Rab plus Rc.
Sir, suara tak ada.
Suara.
Automatically will be on mute. Alright. Okay, so I will explain on the again on the Kelvin bridge. Okay, I will explain on the Kelvin bridge. Okay, so the next for bridge for DC is the Kelvin bridge lah. So that I mentioned to you before this, the Kelvin bridge, the function of Kelvin bridge is to measure the low resistor. Okay, so actually the Kelvin bridge is the similar like Wheatstone bridge. Okay, but we have to modify. The difference is this part, the Ry here, right? So this modification is to eliminate the effect of constant and lead resistance when measuring the unknown low resistance. They mentioned to you the function of the Kelvin bridge to measure the low resistor from 1 ohms to 1 micro ohms. Okay, 1 ohms to 1 micro ohm that the range from to measure the resistor using the Kelvin bridge lah. All right. Okay, you can see this one. So when we put the galvanometer here in point A, this is point A. All right. So this means Rx will be plus with Ry here. Okay, Rx will be plus with point here. So this resistor will be plus with the resistor. That means our Ry will be added to the Rx, resulting the high indication of the Rx. Okay, when we put the galvanometer here in point C here, okay, point C here, all right, so that means our Ry will be plus with R3, and then the Rx will be lower than actual value. Okay, this one will be lower. Okay, but when we put the galvanometer on the point here and the B, okay, so this one will be okay, the equal lah. Okay, the equal, that means the resistor here, okay, the resistor we call the resistor RB will be plus with R3. Okay, this one RBC will be plus with Rx. Okay, we will put at the center lah. Okay, this similar like Wheatstone bridge lah. This similar like Wheatstone bridge, and then from this one we can do the ratio. Right, you can see this is the ratio. So the RCB over RAB equals to R1 plus R2. Okay, this one the ratio will be R1 plus R2 lah. Okay, this, okay, for example, RAB over RBC equals to, okay, this ratio lah. Okay, R1 divided by R2. Okay, and the unresolved balance equation for the bridge give the relationship. All right, so this is a equation. You can see this one. So, right, so this come from this one. All right, you can see this one. When we put here, okay, we put at the B. All right, so that's why you can put this one Rx plus. You can see this one Rx plus RCB. All right, and also this one R3 plus RB here. Okay, R3 plus RB here. So that's why we can get this equation. Okay, that mentioned to you RY equals to, okay, RAB plus RCB lah. That's we get the RY. Okay, and then this formula from this one, and then from this one we can simplify it to the equation lah. Okay, this equation. Okay, R1 over RAB equals to R1 plus R2 divided by R2. Okay, so and then substitute this equation. All right, at the end you can get like this lah. Okay, this is equation for calculate the RCB. Okay, actually the RCB and RAB is the same. You can see this one, it's the same. Okay, but this one is the different is the R1 and R2. Okay, formula will be almost same lah. Okay, this one to calculate the resistor for the CB. Okay, the point from CB, R1 multiplied by RY. Okay, divide by R1 plus R2. Okay, and then for calculate the RAB here, point AB equals to R2 multiplied by RY divide by R1 plus R2. Okay, that is formula lah. Actually, this derive is to get this formula, to get this RB, to calculate the RB, and also to calculate the RCB. Okay, resistor. Okay, on this part, to calculate the resistor here. Okay, we calculate. Okay, for example, we have assume this. We have another resistor here, and also we have another resistor here. Okay, this called as the RAB, and also this one we call the RBC. Okay, RBC, this one. That is formula to calculate the resistor. Okay, that position from AB and also CB. Okay, using this formula. Okay. All right. And the end, after substitute the formula, both formula, we can calculate the Rx. Actually, this Rx similar like Wheatstone bridge. Okay, this formula similar like Wheatstone bridge. When we put the balance equation, that means we put on a galvanometer on this part, on the B, so automatically at the end we can get like this lah. Okay, formula for Rx equals to R1 multiplied by R3 divided by R2. Okay, that is formula lah, the last formula. Alright. Okay, so I think that's all for today. Okay, that's all for the DC bridge. Okay, maybe next week we go for the AC bridge. Okay, that I mentioned to you for DC bridge, we have two bridge. Okay, first is the Wheatstone bridge, and second one we have the Thevenin bridge lah. Okay. Okay, so maybe after we finish for the AC bridge, we go for the tutorial for chapter DC and AC bridge, and also for the oscilloscope. Okay, actually the chapter for oscilloscope is more on the theoretical. So the fundamental of the oscilloscope, how the component inside the oscilloscope. But for the calculation, only how you measure the waveform, okay, waveform of the oscilloscope lah. Okay, to measure the amplitude, to measure the frequency, to measure the period. That is on the calculation lah. Okay, for example, like our final exam for this semester that I mentioned to you. So actually we reduce the number of theoretical, more on the calculation lah. That's why on the chapter oscilloscope we focus on how you measure the waveform lah using the oscilloscope. Okay, So maybe after finish on the chapter 6 on the AC, we go for the tutorial lah, for tutorial oscilloscopes and also the DC and AC bridge. Okay guys, boleh? Right, so tomorrow no class, so just prepare for your test, okay? So if you have any question, you can ask on the group, okay, WhatsApp group. I will try to answer on the WhatsApps, okay? And then we'll be see on Thursday, Thursday at 8 to 10 p.m. Okay, so they mentioned to you the they mentioned to you. So the test will be covered for the chapter 1 and chapter 2. Chapter 1 will be on the introduction to the instrument and measurement. Okay, chapter 2 will be DC. All right. So for chapter 1, I mentioned to you, we have the question. We have one question, but we have two. We have two another sub question. Question number 1 will be on the. We give a table, so you have to from this table you have to get the decisions. Okay, you have to get the standard deviation and so on. You can check on the tutorials. The example on the tutorial. And question number 2 will be limiting error. Okay, we give the limiting error, so you have to calculate the voltage or the current based on the given on the question. Okay, for question number 2, okay, on the DC, first question we have two sub question. Question number 1 is the multi-range emitter, and question number 2 will be multi-range voltmeter lah. Okay, we put some multi-range, so you have to calculate the RA, RB, and so on. Okay, all right. Okay, if any questions so far, okay. Okay, if no questions, so I will stop here. All right, so I mentioned to you, so tomorrow no class, so you just focus on your midterm. Okay, if you have any question, you can ask me on the WhatsApp groups. All right, so good luck for your midterm test on this Thursday. Okay, so everything you can contact me on the WhatsApp group. Okay, thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir. Thank you, sir.
Okay, welcome.